Hey there, welcome back to the channel. In this tutorial, we will explore some key concepts in Python programming that are essential for every beginner. Let's dive in. Let's consider that we want addition of two numbers and we print the number. The memory will temporarily store the result of addition, which is 4 in this case, and then dump it after printing the number. On the other hand, if we assign a value of 7 to a variable x, x appears and points to memory address 98, showing how x references the object. This means we can retrieve x from memory whenever we need it. This is why we need to store all the numbers in variables, so that we can use those variables instead of numbers themselves. Consider another example here to show the importance of variables in Python programming. The first line of code assigns Bob's salary variable with a value of 25,000. The name and memory are updated accordingly. Next, Tom's salary is assigned with a value of 30,000, and it is noticeable that in memory Tom's salary points towards the value of 30,000. The program then assigns Bob's salary with Tom's salary. Please observe the memory, where both Tom and Bob's salary variables point towards 30,000 and other constant is dumped. Let's use the variable name Tom's salary to update the value by multiplying it with a constant. Now again, using the variables Bob and Tom's salary to calculate the total of salary. As a result, a new variable has the value of sum of both salaries. This example shows how variable naming makes it easy for the programmer to track and update the values without worrying about the numbers and using meaningful names. Let's start with a quick activity. As people hop on the bus, you track the number of passengers by typing in the num people box. This box acts like a variable in programming. It stores changing values. And for the riddle's twist, when asked, what's the bus driver's name? The answer is you, because you're driving the bus. In a program, variables like num people store values, and assignment statements like x equals 5 assign values to these variables. The left side holds the variable, while the right side can be any expression that calculates a value. Just like updating the number of passengers, variables keep track of data as it changes. Alright, let's level up our coding game. Think of variables as memory boxes, and in each box, we store different values. For example, x equals 5 drops 5 into x's box. Then, y equals x plus 2 takes x's value. 5 adds 2, and now y holds 7. But when we update x with x equals 3, the old value is gone, and y stays at 7. In programming, the equal sign means store this value, not balance both sides like in math or in algebra. Assignments follow a sequence. Each step updates a variable, one at a time. The latest value always wins. Now, it's time to test your understanding of the concepts we just discussed. Type your answers in the comments below and show your programming knowledge. Don't just sit back, jump in and show everyone what you've got. Coding is all about practice, so sharpen those skills and rise to the top. Let's go. Here's your first challenge. Is x equals 1 a valid assignment statement or not? Think it through and type your answer in the comments below. Let's see who's got it right. Here's the next one. Is x equals y valid or invalid? Drop your answer in the comments below. Let's see who's quick to figure it out. Alright, here's question number 3. Is x equals y plus 2 valid or invalid? Think fast and type your answer in the comments. Who's ready to crack this one? Now take a moment to review your answers one by one. Compare them with what you have learned and share in the comments how many you got right and how well you grasped the concepts. Let's tackle question 4. Is x plus y equals 3 a valid assignment statement, or is it a no-go? Share your thoughts in the comments below. Let's find out who's on point. Here comes question 5. Is x plus y equals y plus x a valid statement, or is it a no-go? Thinking about it and drop your answers in the comments. Let's see who's got the right coding intuition. Take a few moments to go over each of your answers carefully. Match them with what you've learned, and in the comments, mention how many were correct and how confident you feel about your understanding of the concepts. Now let's dive deeper and further check your understanding of variables and assignments with a few more questions. Get ready to think critically and showcase what you've learned. Here's the first question. Given the variables x lower 9 and y, geom x plus 1, what do you think the value of y is? Share your answer in the comments below and let's see who gets it right. Here's the second question. With x are 9 and y each x plus 1, what do you think the value of x is? Type your answer in the comments and let's see who can nail this one. Here comes question 3. Given x large 9, y add x plus 1, and then we update x to 5, what do you think the value of y is now? Drop your answer in the comments below and let's see who can solve it. Please take some time to evaluate each of your answers separately. Consider what you've learned and how well you understand the concept. Let's explore a key concept. A variable can appear on both the left and right sides of an assignment statement. This flexibility allows for dynamic calculations and update values easily. For example, when we assign x star 1, then the statement x star for x is 20 takes the current value of x, which is 1, multiplies it by 20, and assigns 20 back to x, overwriting its previous value. In the next step, executing x star x by 20 again multiplies the current value 20 by 20, resulting in 400 and overwriting the previous value of 20. Remember, only the latest value is held in x. After these operations, x now holds the value 400. This shows how assignment statements can effectively update a variable's value throughout the program. Now, it's time to test your understanding. Let's see how well you can apply what you've learned about variables on both sides of an assignment statement. I'll ask you some questions, and I want you to think carefully before you answer. Ready? Here's your first question. Can you indicate the value of x after these statements execute? Take a moment to think about it. What do you think the final value of x will be? Share your answers in the comments below. Let's see who gets it right. Now let's move on to the second question. Can you figure out the value of x after the following statements execute? Think it through carefully. What do you think the final value of x will be after these operations? Type your answers in the comments below. Let's see who gets it right. Let's dive into the third question. What do you think the value of x will be after the following statements execute? Take your time to calculate it. What do you think the final value of x will be after these statements? Drop your answers in the comments below. Pause for a moment to assess each of your answers one by one. Reflect on your learning, and in the comments, let us know how many you got right and how well you grasped the concepts. Here's your fourth question. What do you think should go in the blank to properly increment the value of y? Share your answers in the comments below. Let's see who can complete the statement correctly. Take a moment to look over your answers one at a time. Think about what you've learned and let us know how many you got right and how well you understand the concepts. In programming, names like x in x⁵ are identifiers or variable names used to store values. There are certain rules that we need to follow to name the variables. Identifiers or variable names are used for variables and must start with a letter and can be a combination of letters, digits, and underscores. Python is case sensitive, so names like cat with capital C and cat with small c are considered different. Invalid names include those starting with digits, like 42C, or containing spaces or special symbols. Double underscores are allowed, but should be avoided for regular variables due to their special meaning in Python. It's recommended to use descriptive names like temperature or age for clarity. Reserved words like true or and cannot be used as variable names. Please go through all the rules before we move to next slide. On the next slide, I've got a few quick questions for you to review your understanding of variable naming. Here's your first challenge. Take a look at this name, numcars. Is it a valid identifier in Python? Think carefully about what we've discussed regarding naming rules. Think carefully and type your answer in comment section. Let's see if you can spot the correct answer. Now let's move on to the next one. Check out this identifier, numcars1. Is it valid in Python? Take a moment to recall the naming conventions we discussed. What's your answer? Let's see if you can get this one right too. Here are the correct answers. Compare them with your responses and see how they match up. Now, here comes the third challenge. Take a look at this name, numcars. Is it a valid identifier in Python? Think back to what we've covered about starting with letters or underscores. What do you think? Think about it and type your answer in comments. Here's your fourth question. Check out this identifier. Numcars2. Do you think it's valid in Python? Remember, we talked about identifiers that start with double underscores. Think wisely. Let's see if you can ace this one. Here are the correct answers. Compare them with yours to see how you did. Now, for your fifth question, take a look at this identifier, numcars. Do you think it's valid in Python? Think back to our discussion about spaces in identifiers. What's your answer? Let's find out if you can get this one right. Now, let's move on to the sixth question. Take a look at this identifier. Third place. Is it valid in Python? Keep in mind that identifiers need to start with a letter or an underscore. What's your answer? Type your answer in comments for me to review. Here are the correct answers. Check them against your responses to see how you performed. Now, let's dive into the seventh question. Check out this identifier. Third place. Is it valid in Python? Remember, identifiers can end with an underscore too. What do you think? Tell me in the comments section if you get the right answer. Now let's take a look at the eighth question. What about this identifier, third place? Is it valid in Python? Think about the special characters we discussed. Think about it carefully. Can you figure this one out? Here are the right answers. Take a look at them and see how they match up with your responses. Now let's tackle the ninth question. What about this identifier? Output. Is it a valid name in Python? Recall what we've talked about regarding naming conventions. Can you get this one right? Think carefully and share your answer in comments. Now let's move on to the 10th question. Take a look at this identifier. Return troik copy. Is it valid in Python? Remember our discussion about reserved keywords. What do you think? Can you solve this one too? Think about all the questions carefully and give your answers in comment section. Here are the accurate answers. Review them and see how they align with your responses. Now that we understand identifiers, let's explore styling guidelines. Python prioritizes readability, so using meaningful names for variables is crucial. Following naming conventions makes your code clearer and easier to understand. For example, the first one says the number of students attending the class. The less meaningful names column shows names like NS, Num, or Nu. While valid, these names don't provide much context, making the code harder to understand. On the other hand, Num students from the more meaningful names column instantly clarifies that it represents the number of students. This simple adjustment greatly improves code readability. Let's walk through the other rows. For a television size, using STV or size doesn't provide much clarity, but when you switch to diagonal TV size in inches, it becomes crystal clear what you're referring to. Now, moving on to some special cases like mathematical constants. In row 3, for the ratio of a circle's circumference to its diameter, using just P is too vague. But PI is a universally recognized name, making it a far better choice. Lastly, for the number of jelly beans guessed by a user, less meaningful names like guess or num don't convey much. By using num guessed or jelly beans or user guessed jelly beans, your variable clearly states its purpose. So, always use meaningful descriptive names for your identifiers. It makes your code easier for both you and others to understand and work with. Python has reserved words or keywords with specific meanings in the language. These words, like if, while true, and return, are essential for controlling program flow and defining structures. Using them as variable names confuses Python, leading to errors. To avoid issues, familiarize yourself with the list of reserved words and ensure you don't use them when naming variables. After exploring the list of reserved keywords, here's a quick challenge for you. Use the tool below to test both valid and invalid names. Let's see how well you've grasped the concept. Think about it carefully And if you correctly identify the valid identifier, type your answer in the comments. You've likely seen numbers like 98.6 or 666.667, but what exactly are they? Well, floating point numbers are real numbers that include decimal points. The name floating point is because the decimal point can appear anywhere in the number. It floats around. And in programming, we use a special data type called float to handle these floating point numbers. When you write a floating point literal, you always include a fractional part, even if that fraction is 0. So whether it's 1.0, 0.0, or 99.0, you're telling the computer that these are floating point numbers. Now, when working with really large or small numbers, we can use scientific notation. Now that we've covered what floating point numbers are, let's dive into a real-world program using them. This program reads a distance in miles, converts it to a float, and calculates the time to fly or drive that distance. Flight time is calculated by dividing the distance by 500.0 flight speed and drive time by 60.0 driving speed. It then prints the distance and the respective times. For example, for 450 miles, it takes 0.9 hours to fly and 7.5 hours to drive. This demonstrates the practical use of floating point arithmetic. Floating point objects in Python have a limited range of values they can represent. For a standard 32-bit installation, the maximum floating point value is approximately 1.8 x 10308, while the minimum is around 2.3 x 10308. If you attempt to assign a floating point value outside this range, you'll encounter an overflow error. This error occurs when a value is too large to be stored in the memory allocated by the interpreter. I'll present some questions, and you need to choose the right variable type for each one. Think carefully and type your answers in the comment section for me to review. Let's test your understanding of variable types. Here's the first question. Choose the appropriate type for a variable to represent the following item. Take a moment to think about your answer and share it in the comments below. Now, let's move on to the second item. Choose the correct variable type for the following statement. Think it through and drop your answer in the comments. Let's see how well you're grasping these concepts. Here are the correct answers. Compare them to your own to evaluate your performance. Now, here's your third question. Choose the right variable type for the following statement. Think about the options carefully and share your answer in the comments below. Next, here's the fourth question. What variable type would you use for the following item? Give it some thought and post your answer in the comments. These are the correct answers. Match them with yours to see how you scored. Let's move on to the fifth question. Which variable type would be appropriate for the following scenario? Think about your answer and share it in the comments below for me to review. Here is the right answers. Check them against yours to see how well you did. Let's explore the concept of reducing the output of pi. Pi is an irrational number with an infinite non-repeating decimal representation. In Python, the math module defines pi as a floating point number, and while it defaults to displaying 15 digits after the decimal, you can format it for specific precision. For example, using print statement with only 4 decimal point output prints pi to 4 decimal places, rounding the last digit while keeping the actual value unchanged. This feature is particularly useful in mathematical and scientific computations that require a specific level of precision. Now that we've explored the concept of reducing the output of pi, it's time to test your understanding. I have prepared some multiple choice questions to gauge how well you grasp this topic. Think carefully about each question and choose the best answer. Here's your first question. Which argument would you use to complete the print function so that it outputs 2 digits after the decimal point? Take a look at the code snippet below and select the correct option. Think carefully about your answer and share it in the comments. Here is the correct answers. Compare them with yours to see how you measure up. Now, let's move on to the second one. What will be the output of the following code? Take a moment to analyze it before selecting your answer. Think about it and drop your answer in the comments for me to review. Check out the correct answers below and see how your results stack up. Now, let's tackle the third question. What do you think will be the output of this line of code? Take a look and select the correct answer. Think about this question and share your answer in the comment section. Here is the correct answers. See how your results compare. Now let's introduce the main tools. Operators. These symbols handle the heavy lifting: addition, subtraction, multiplication, division, and exponentiation bring calculations to life. The addition operator is plus, like in x plus y. The subtraction operator is minus, used in x minus y. You can also negate values like x plus. For multiplication, we use asterisk, like in x multiplied by y. Division, that's done with backslash, as in x divided by y. And for exponentiation, we use double asterisk, so it means x to the power of y. These operators enable complex calculations and control your program's behavior. Arithmetic expressions are the backbone of coding, ensuring your program works as intended. Now that we've covered the essentials, it's time to put your knowledge to the test. Ready to see how well you've grasped arithmetic expressions? Let's dive into some quick questions to check your understanding. Think carefully and type your answers in the comments for me to review. Here comes the first question. Ready? Indicate which of the following is a valid expression. Remember, x and y are variables. Let's see how sharp your understanding is. Take a moment to think before choosing your answer. Now let's move to the second question. Identify, is this expression valid or invalid? Think about the concepts we have discussed above and type your answer in comments. Let's see what you've got. Here's the next question. Is x a valid expression or not? Think carefully about your answer. Let's see if you can nail this one. Now, let's move on to the fourth question. Is 2 a valid expression? Remember the basic concepts about the expressions. Think about the answer carefully and share your answers in the comment section. Take a look at the correct answers and find out how your results measure up. Now let's challenge with question 5. Is 2x a valid expression? Take a moment to analyze it. Remember, every character in your expression matters. Can you figure this one out? Let's see what you come up with. Now let's move to question 6. Is this expression valid or not? Take your time to think it over. Remember the previous concept we have discussed above. Can you crack this one? Let's find out. Here comes the last question. Identify that the following expression is valid or not. Think about it carefully. Assignment statements are key to storing results in programming. Can you identify the validity of this expression? Let's see your answer. Review the correct answers and discover how your results match up. Now, let's take it a step further and explore how expressions capture behavior in programming. These next questions will really test your understanding and help you see how expressions shape the flow of a program. Think about the questions carefully and type your answers in the comment section for me to review. Let's dive into the first question. Does the expression 6 plus num items correctly capture the behavior of 6 plus num items? Take a moment to think. Does this expression behave as intended? Think about it and type your answers in the comments. Now let's move to the second question. This one's all about multiplication. Does the expression 6x num items correctly capture the behavior of 6 times num items? Think about the question carefully. Let's see how well you understand how expressions behave. Now let's test your understanding of division in expressions. Ready for question 3? Does the expression total days 12 correctly capture the behavior of total days divided by 12? Division plays a crucial role in programming logic. Does this expression behave as expected? Take a moment to think it over. Examine the correct answers and see how your results align. Let's move to question 4. This one's all about multiplication again. Let's see how sharp your expression skills are. Does the expression 5t correctly capture the behavior of 5 times t? Does this one match the intended behavior? Let's find out. Type your answers in the comment section for me to review. Now let's tackle question 5, where we dive into negative values. Ready? Does the expression user val correctly capture the behavior of the negative of user val? Think carefully. Negative values can change the whole meaning of an expression. Does this one get it right? Now, let's explore something a bit different with the last question 6. Are you ready for factorials? Does the expression n correctly capture the behavior of n factorial? Factorials are a key concept in math and programming. Does this expression nail it? Let's see how well you understand it. Look over the correct answers and find out how your results correspond. Now that you've tackled some practice questions, let's dive into an essential concept: evaluation of expressions. Expressions follow a specific order, much like mathematics, called precedence rules. These rules determine the order in which parts of the expression are evaluated. The table explains the precedence rules for evaluating expressions in programming. It outlines the processing order. First, parentheses are evaluated. Next, the exponent operator. Then, unary minus for negation, followed by multiplication, division, and modulus, which share equal precedence. And finally, addition and subtraction. Operators of the same precedence are evaluated left to right, except for the exponent operator, which is evaluated right to left. Now that we've covered operator precedence, it's time to challenge your understanding with some questions. In the first question, consider the expression dot, which operator is evaluated first. Next, look at for the second expression. Can you identify the first operator here? In the third expression, analyze that which operator comes first. For the fourth expression, examine and indicate the first operator evaluated. In the fifth expression, what about this one? Finally, in the sixth expression, can you identify the order of operations for the first, second, and third operators? Let's see how well you can apply these concepts. Think about these questions carefully and share your answers in the comment section. Now that we've covered the precedence of arithmetic operators, it's time to check your understanding. Let's see how well you can evaluate expressions while applying those rules. Get ready to put your skills to the test with some fun challenges. Here comes the first question. Select the expression in which the parentheses match the evaluation order of the original expression. Think about it. Which option keeps the original order of evaluation? Share your thoughts in the comment section. Next, move to the second question. Select the expression in which the parentheses match the evaluation order of the original expression. Which option accurately reflects the original order of evaluation? Let us know your answer in the comments for me to review. Now, let's move into the third question. Select the expression in which the parentheses match the evaluation order of the original expression. Which option correctly maintains the original order of evaluation? Think about it carefully and share your answer with us. Take a moment to go over each of your answers. Compare them with what you've learned, and in the comments, share how many were correct and how well you understand the concepts. Here comes the fourth question. Select the expression in which the parentheses match the evaluation order of the original expression. Which option accurately reflects the original order of evaluation? Let's find out. Let's move to the fifth question. Select the expression in which the parentheses match the evaluation order of the original expression, x divided by 2 plus y divided by 2. Which option correctly maintains the original order of evaluation? Think about it and share your answer in comment section for me to review. Take some time to review each of your answers. Match them with what you've learned and comment on how many you got correct and how confident you feel about the concepts. Here comes the last question 6. Can you determine the value of total count? What do you think the final value is? Choose from the options and explain your reasoning behind your answer. Can you calculate it correctly? Share your thoughts in the comment section. Go through each of your answers carefully, compare them to what you've learned, and comment on how many were correct and how well you understand the concepts. Expressions in Python are combinations of variables, values, operators, and function calls that evaluate to a value. Think of expressions as the building blocks of Python programs. Whenever you want to perform a calculation, you'll need an expression. Arithmetic expressions in Python allow you to perform basic operations like addition, subtraction, multiplication, and division. These are similar to the ones you do in regular math but use Python operators. Plus for addition, minus for subtraction, asterisk for multiplication, slash for division, double asterisk for exponentiation power, and percent for modulus remainder of a division. Now, let's jump into a simple Python program that calculates the total cost of leasing a car using an arithmetic expression. The provided Python program calculates the total cost of leasing a car by gathering three user inputs: the down payment, the monthly payment, and the number of months for the lease. It then performs a simple arithmetic operation to determine the total cost. The calculation is done by multiplying the monthly payment by the number of months and then adding the down payment. This total is stored in the variable total cost. Finally, the program prints the total cost, formatted to 2 decimal places for better readability. This program demonstrates the use of basic arithmetic expressions in Python, specifically addition and multiplication, and highlights the ease with which Python handles user input and formatted output for financial calculations. Alright, after discussing the concept of Python expressions, let's put your Python skills to the test. Can you write a simple program using an arithmetic expression to perform a basic calculation? Think about the questions carefully and comment your solutions in the comment section. Let's see who's nailed it. Here comes the first question. If we remove the parentheses from the given expression, will this give the same result as before? Think carefully. Are parentheses really that important? Let me know your answer in the comments. Next, move to question 2. If we changed our approach and used 2 assignment statements, would this give us the same total cost as our original expression? Think about the question. Can breaking it down into steps change the outcome? Share your thoughts in the comments below. Review each of your answers, compare them with what you've learned, and share in the comments how many you got right and your grasp of the concepts. Now that we've mastered arithmetic expressions, let's discuss a key aspect of writing clean code: spacing around operators. A good practice in Python is to include a single space around operators. For instance, use num items plus 2 instead of num items plus 2. This small adjustment greatly improves code readability. However, an exception exists for the minus sign used as a unary operator, as in x coordinate equals negative y coordinate, where no space is needed to indicate a negative value. Now, after understanding the concept, it's time to put your understanding of spacing around operators to the test. Think carefully about each question and remember the importance of spacing. Share your answers in the comment section for me to review. Here are some expressions that don't quite follow the best practices for spacing around operators. Rewrite each statement to include a single space around the operators for enhanced readability. Let's see how you can transform these lines. Think about these questions and drop your answers in the comments below, and let's make our code clean and clear together. Check each of your answers. Align them with what you've studied and how well you understand the material. Compound operators provide a more concise way to update variables without needing to repeat the variable name. Instead of writing the full expression every time, you can use compound operators to shorten the code. This table illustrates various compound operators used to simplify mathematical operations in programming. It provides 5 examples: addition assignment plus equals, subtraction assignment minus equals, multiplication assignment, asterisk equals, division assignment slash equals, and modulo assignment percent equals. Each of these compound operators reduces redundancy by removing the need to repeat the variable name on both sides of the assignment, making code more concise and easier to read. Now that you've grasped the concept, it's time to apply what you've learned about compound operators. Take your time with each question and remember, accuracy is key. Drop your answers in the comments for review. Here comes the first question. Imagine num atoms starts at 7. What will num atoms be after this operation? Think it through and share your answer in the comments below. Next, here's the second question. If num atoms begins at 7, what will it become after applying the following operation? Think about it and drop your answers in the comments. Let's see how you handle this one. Look over each of your answers. Compare them to your learning. and comment on how many you got right and how well you understand the concepts. Now move to the question 3rd. Can you rewrite this statement using a compound operator? Think about the question carefully and share your thoughts in the comments for me to review. Here comes a 4th question. Can you rewrite this statement with a compound operator? If it's not possible, simply type not possible. Think about the question and drop your answer in the comment section. Look over your answers, check them against what you've learned. Now, here's a question to test your understanding. The following code correctly assigns num years with an integer value of 2 billion. Think carefully. Is the use of commas correct here? Type your answer in the comments. Go through your answers one by one, compare them with what you've learned, and share in the comments. In Python, the division operator is used to perform division, and it always returns a floating point number. No matter if you're dividing two integers, you'll get a float in return. Here are some quick examples. 20 divided by 10 gives you 2.0, and 5 divided by 10. That returns 0.5. Notice how all the results are decimals, even if the division comes out exact. That's Python's way of making sure. Here comes the first question. What do you think is the result of 12 divided by 4? Remember, we're looking for the floating point answer. Now how about 5 divided by 10? This one should give you a decimal. Think carefully. Let's get a little tricky. What will return? Hint, one of the operands is a float. And finally, what happens when you try 100 divided by 0? Type error if the program crashes. Remember the concept and drop your answers below, and I'll be reviewing them. Review your answers in light of what you've learned, and comment on how many you got right and how comfortable you feel with the concepts. The modulo operator, represented by %, is one of Python's basic arithmetic operators, along with plus, minus, asterisk, slash, and double slash. It returns the remainder of a division between two numbers. The modulo operator is particularly useful for checking divisibility and finding remainders in various applications. Now it's time to practice what you've learned about the modulo operator. Here are the questions. The first one is, what is the result of 50 modulus 2? The second one is, how about 51 modulus 2? The third one is, evaluate 78 modulus 10. The fourth question is, what does 596 modulus 10 return? Finally, the fifth question is, what will 100 modulus 1 /2 give you? Take your time, think through each expression, and drop your answers in the comments. Let's see how you did. Review your answers individually, compare them to what you've studied, and let us know in the comments how many were correct and how confident you feel with the concepts. The modulus operation is a fundamental technique used to extract digits from a number. In the given example with the number 927, we use modulus, %, and integer division to break it down. First, applying use over modulus 10 gives the remainder when 1927 is divided by 10, yielding the last digit, 7. To remove this digit, we perform integer division with user val 10, reducing 927 to 92. Next, we apply the modulus operation to 92, temp val modulus 10, extracting the tens digit, 2, and then divide 92 by 10 to get 9. Finally, using modulus on 9 gives the hundreds digit, which is 9. This process efficiently breaks any number into its individual digits using repeated modulus and integer division. Alright, it's time to test your knowledge. Let's see how well you've grasped the modulo example. Take a moment to think through each question and share your answers in the comment section for me to review. Here comes the first question. If you're given a non-negative number x, which of these expressions will give you a result within the range of 5 to 10? Now move to the second question. Let's say you're working with a non-negative number x. Which of the following expressions will give you a result between -10 and 10? Examine each of your answers, match them with what you've learned, and share in the comments how many you got correct and your understanding of the concepts. Let's move for the third question. Imagine you have a number x, like 693. Which expression will give you the tens digit? In this case, we want to extract the 9 from 693. Here comes the fourth question. As you have a 16-digit credit card number stored in X, which expression will give you the rightmost 4 digits? Take a look at each of your answers, compare them with the knowledge you've gained, and let us know in the comments how many you answered correctly and how well you grasp the concepts. Unicode is a universal system that assigns a unique code point to each character, enabling text representation in programming languages like Python. With over 1 million code points, Unicode covers everything from letters and symbols to emojis, allowing programs to handle text in any language or format. This table lists the encoded text values, Ascii, ranging from decimal 32 to 126, displaying each corresponding character. Starting with the space character at decimal 32, it includes various punctuation marks such as exclamation mark, quotation mark, number sign, and dollar sign, followed by numerical digits from 0 to 9, 48 to 57, uppercase letters from A to Z, 65 to 90, and lowercase letters from A to Z, 97 to 122. It also features additional symbols like brackets, backslashes, and tilde. This comprehensive mapping illustrates how each character in this range is represented by a unique decimal code, demonstrating the fundamental role of Ascii in text representation within computing. Escape sequences are special character combinations used to represent non-visible characters like formatting commands. For example, \n represents a new line. The backslash signals a special command, allowing control over text layout such as line breaks, tabs, and quotation marks. This table illustrates common escape sequences used in programming, detailing their functions, example code, and resulting output. The sequence \/ represents a literal backslash, which outputs \home users. The escape sequence \\ allows single quotes within single quoted strings, producing name John O'Donnell. Similarly, \" appear in double quoted strings, such as he said hello friend. The \n sequence adds a line break to the output, while \t inserts a tab space for indentation, allowing text to be formatted across multiple lines or with indents. These escape sequences give programmers the ability to format text precisely in their code. After discussing the concepts of escape sequences, let's test your understanding with some practice question. Think carefully about the questions and share your thoughts in the comment section below. Here comes the first question. What will be the output of this Python code? Take a close look at those backslashes and share your answer in the comments. Review your answer, cross-check it with what you've learned, and share in the comments how confident you are in the concept. Now, it's time for the second question. What will be the output of the following code? Think about the question carefully and share your answer in the comment section. Let's see how well you understand escape sequences. Evaluate your answer, verify it with your knowledge, and let us know in the comments how confident you are in the concept. Here's your third question. What will be the output of this Python code? Remember about the concept of escape sequences and share your answers in the comment section. Let's see who nailed it. Check your answer, compare it with what you've learned, and share your confidence level in the comments. Here comes the next question. Can you complete the following code to output a single backslash? Think carefully about how escape sequences work and drop your answer in the comments. Let's see who can crack this one. Here comes the last question. How can you assign the file path c:\/ file.doc to a variable without interpreting the backslashes as escape sequences? Let's see how well you understand raw string literals. Think about this question and share your answer in the comment section for me to review. Go through your answers, compare them to what you've learned, and share in the comments how many you got correct and your level of understanding. In our programming journey, we've explored key concepts such as variables, assignment statements, and identifiers for better readability while avoiding reserved keywords. We learned about floating point numbers, formatting outputs, arithmetic expressions, and essential operations like division and modulo for calculations. Additionally, we covered text representation, escape sequences, and Unicode, providing you with valuable skills for effective text manipulation. Keep practicing to enhance your coding journey. If you enjoyed this tutorial, please like, comment, and subscribe to our channel. See you in the next video.